When DB file scattered read wait event occurs, we can call this multi-block read. While doing full table scan or index fast scan, lot of blocks need to be fetched from disk to buffer, and they will be in buffer in a scattered manner, because these buffers in the buffer cache will not contagious. And during this activity, it need to find lot of free buffer, which leads to this wait event. Solution: avoid full table space if possible. If large tables, consider using partitioning. Check whether proper indexing is in place to avoid full scan. What is DB file parallel read wait event? What is DB file sequential read wait event? Sequential read means single block read. This is largely due to index full scan or index scan with order by clause. When rows in the table are in random order, then clustering factor will be very high. I.e. more table blocks need to be visited to get the row and index block. Also, when index blocks are fragmented, then more number of blocks need to be visited, which can cause this wait event. Redo allocation latch contention? Redo copy latch contention? What is buffer busy wait? What should be the approach to fix it? Buffer busy wait is due to excessive logical I/O. This wait happens when server process got a latch on the hash bucket, but another session is holding the block in buffer. Either it is writing to that block or maybe buffer getting is flushed to disk. Sometimes this is known as read by other sessions. To troubleshoot this issue, first we need to find out the responsible object. We can get the P1 file _ID, P2 block, P3 reason, details of the query from $session_wait. And by using the P1 and P2 values, we can get the segment details from the DBA_extents. Then we need to check the segment is of which type. If it is an undo, then need to increase the size of undo table space. If it is data block, means the query might be inefficient. Maybe we need to try moving the hot blocks to a D. What is latch, cache buffer chains, CBC, wait event? Each buffer in the buffer cache has an associated element in the buffer header array. These details are available in $bh. Buffer header array is allocated in shared pool. These buffer header arrays stores attribute and status details of the buffers. These buffer headers are chained together using double linked list dot and link to hash bucket. And there are multiple hash buckets, and these buckets or chains are protected by latch cache buffer chain. If a process want to search or modify a buffer chain, then first it need to get a latch I.e. CBC latch. So when multiple users want to access the same block or the other block on the same hash bucket, then there will be contention for getting a latch. So when contention is severe, I.e. process is finding it difficult to get a latch, then this latch, CBC wait event will occur. Not only accessing the same block, but when simultaneous insert, update runs on a same block, then cloned buffers copies also gets attached to same hash bucket, and it increases the buffer chain length. So process after getting the latch, takes more time to scan through the long chain. The wait event occurs when logical I/O is high. So to avoid this wait event, we need to find a way to reduce the logical I/O. Solution. The solution depends upon what query is causing the issues. If the issue is due to null of users accessing the same dataset, then we can increase the PCTFRE of table/index, so that there will less rows per block. And the data will spread across multiple chains. Latch, cache buffer LRU chains? This wait event occurs when physical I/O is high. When the requested block is not available in buffer cache, then server process need to read the block from disk to buffer cache. For that it needs a free buffer. So for this, server process search through the LRU list to get the free block. And search or access a LRU list, first it needs to get a latch, which is called latch, cache buffer LRU chain. Also when the DBWR writes the buffers to disk, first it scans through LRU list to get the dirty buffer which need to flushed. For this purpose also it needs to get a latch. Below are some of the activities which are responsible for this wait event. Small buffer cache means, very frequently dirty blocks need to be written to disk very often, which will increase the latch contention. Very lot of full table scan means, it need to find lot of free buffer to read the data from disk. Means very often latch need to obtained. What is free buffer wait event? Reasons. DBWR is unable to handle the load. Buffer cache size is small. Why the wait event enc tx allocate ITL entry occurs and how to fix it. Interested transaction list ITL is an internal structure in each block. When a process want to change a data in block, it need to get an empty ITL slot to record that the transaction is interested in modifying the block. Once slots are over, it uses the free spaces available on block. The null of ITL slots are controlled by initrans. Default value of initrans is 1 for table and 2 for table. So concurrent DMLs happens on a block and there are no free ITL slots, then it wait for a free ITL slot, which caused this wait event. To fix this we can increase the initrans value, if still issue present then increase the PCTFREE. Steps to initrans. Alter table initrans 60. But problem is the new value is applicable for the new blocks. So to apply the changes to all the blocks, we need to move the table and rebuild respective indexes. Alter table employee move online. Alter index EMP_ID rebuild online. If after updating initrans also issue is there, then update PCTFRE and move table and index. Alter table employee 320. Alter table employee move online. Alter index EMP_ID rebuild online. What is enc tx index contention? When lot of insert and delete operations happens on a table, contention might happen on the respective index x. Because insert cause index splitting, if the transactions are accessing the index during these splitting, then there will a waiting. There are few solutions which can be applied. But before doing changes, need to be tested thoroughly. Creating a reverse key index, this helps where only inserts happen, but might impact the range scan. Increase free value, this will reduce index splitting. What are different types of mutex wait events? Cursor, mutex X. Cursor, mutex S. Cursor, pin S. Cursor, pin X. Cursor, pin S wait on X. Library cache, mutex X. Library cache, mutex S. What is library cache lock wait event? Below are some reason which might cause this wait event. Reasons. Small shared pool. Less cursor sharing /i.e more hard parsing. Library cache object invalid and reloaded frequently. Huge number of child cursor for a parent cursor, i.e high version count. Non-use of binds by application queries. DDL during busy activity. Solutions. Increase shared pool size. Always run critical DDLs during non-busy hours. Avoid object compilations during peak time. Check query with literates, check cursor_sharing parameter.